Another piece of information that you need for analyzing your data for experiment 7 is the IR spectrum of polysaturine. So this is the spectrum that is posted on Moodle. So it is already up on the Moodle site. You don't need to make a copy of this because it is the same for everyone. What you do want to use is use the spectrum itself to analyze, compare your data to the spectrum, and use this peak table to help you put your peak table together for your own spectrum. So you want to be comparing your peaks to the peaks that are listed in this peak table, okay? And again, that's on Moodle right now. All right, experiment 8. We are going to be doing an experiment that not a lot of sophomore organic lab classes would do, and definitely not a lot of sophomore organic lab classes in the middle of the first semester, okay? So this is pretty good experience that you are getting with this reaction. Now the Grignard reaction, so it's Grignard, it's not Grignard, okay? The Grignard reaction, it is a capital G, because this is someone's name. So Victor Grignard in 1900 came up with this reaction, right? So it's named after him. So you will capitalize your Grignard in your Grignard reaction. And this is an organometallic reaction, so we're going to involve the organic part, the carbon part, but we also have a metal involved. We've got magnesium involved with this reaction. And so the first part of it is we have to make our Grignard reagent. And so we're going to take an alkyl bromide. So you guys have these on your half sheet of paper that you got last week from your lab prof. It shows you what your alkyl bromide is, and then it also shows you the other pieces of the reaction you need to perform. So everyone's varying by what alkyl bromide they have. We're going to react that with magnesium, and we use ether as our solvent. We'll talk about why that is here in a minute. We form this organomagnesium bromide in our case, or it could be in other types of Grignard reagents. It could be an organomagnesium halide if this halide is different, okay? In our case, everybody's is going to have some sort of bromide on there, all right? And so this reagent here has some characteristics that are not like a lot of the other reactions that you've looked at so far in organic lecture. So our carbon, because it is connected to this magnesium bromide, it has a partial negative charge on it. Instead of usually it has some sort of partial positive charge. So in this reaction, it can act like a nucleophile. And so that is part of what makes this reaction so unique. The other part of it, we'll talk about here in a minute when we get to combining this with an aldehyde, is we're going to make a carbon-carbon bond, which is whenever you can make a carbon-carbon bond with a reaction, that's a high-value organic reaction, okay? So this kind of has like double high value. Carbon is going to act like a nucleophile, and we're going to make a carbon-carbon bond, all right? So here's an example of making that organomagnesium bromide. Okay, so here is bromopentane. We react it with magnesium, and we get our organomagnesium bromide here. That magnesium just inserts right in between the carbon and the bromide, all right? So this would be one possibility for a Grignard reagent. Now the reason that we use the ether is because typically in Grignard reactions, you're either going to use diethyl ether or you're going to use THF. And the reason for that is it can coordinate with the magnesium, and so it helps solubilize that magnesium and bring that magnesium into solution to then react with your organohalide, whatever that is. In our case, it's our alkyl bromide, okay? So ether and THF are really good at solubilizing the magnesium. In a little bit, we'll talk about another reason that we use the ether because of its volatility. It helps with our situation as far as setting up the reaction. Now in preparing our Grignard reagent, there's a couple things we need to keep in mind. There's some side reactions that we need to prevent from happening. So one of those is the carbon in our organomagnesium bromide, the carbon attached to the magnesium, since it is a nucleophile, it can act like a weak base, and it can react with things like water or amines or carboxylic acids or alcohols. So we have to be careful of it reacting with water. These other things, as long as we keep these things out of our reaction, will be okay. But in the atmosphere, we've got water. And so we have to be careful with that, because what would happen is if we react with water, we'll get the corresponding alkane of this piece plus BRMG. So basically we get hydroxide of our organomagnesium bromide, okay? Now it always happens that the week we do Grignard, it also is going to be like rainy and damp and things like that when we're trying to keep things really dry. So we'll work extra hard this week. So this is why you're going to dry your glassware. You want to get all of the residual water that is on the sides of your glassware out of it. That's why we're putting it in the oven. The other thing we're going to do to prevent this is we're going to use dry ether. So I'll tell you in a little bit where that ether is going to come from. It's not going to be in the red can. It's special anhydrous ether. So we want to make sure that we keep things as dry as possible and keep all the water out so we don't end up killing our Grignard reagent as we make it. Another thing that can happen is our Grignard reagent can also react with oxygen. And we have oxygen in our air, so oxygen is everywhere. And if it does that, we will prepare this compound, which we don't want to prepare yet. It's similar to what the intermediate that we want here in a little bit. But we don't want that quite yet. So what we're going to do here is we've got the ether that has a high volatility, so that means that it's going to have a lot of ether vapor sitting above the liquid to kind of keep the oxygen out of the reaction. And then we also use cotton balls in any openings that we have in our setup so that we keep that exchange of oxygen to a minimum. The other part is when we're making our Grignard reagent, we're not going to stir the reaction because we don't want to stir oxygen into the reaction, okay? Now the other thing that can happen is our Grignard reagent can react with itself. And so then you get basically the dialkyl compound of our Grignard reagent plus magnesium bromide. So what we are going to do is in the formation of our Grignard reagent, we're going to add our alkyl bromide dropwise so that we don't have too much of it in there sitting there ready to react with itself, okay? So we'll add it dropwise so it's slowly being added and then it's reacting with the magnesium as it's being dropped in there. Yeah?
Joe, we'll split these side reactions in our notebook.
You don't necessarily need to put them in your notebook, but be really aware of them. I would understand what's happening with each of them. So know what happens when it reacts with oxygen, know what happens when it reacts with water, or trying to react with itself, okay? But what we need to do is we need to add things dropwise. So we're gonna have a special setup for our reaction. And we'll show you, we've got, as you always, we have the demo set up in lab itself too. But basically, we're going to finally use our 3-neg flask. So you've had this 3-neg flask in your lab drawer all semester. We haven't used it for anything. We're going to use it this week. In your 3-neg flask, you're going to have your stir bar. So that's why you put your stir bar in it to put it in the oven for this week. Okay, so when you stick it in the oven, make sure your 1-inch stir bar is in there. When you get everything out of the oven, so remember what's going in the oven is your 3-neg round bottom flask, your stir bar, your set funnel without the Teflon pieces, no Teflon pieces in the oven. Your condenser and stoppers will go in the oven, okay? When you get everything out of the oven, you're gonna be first really careful handling it. So remember, hot glass, cold glass, they both look the same. So be careful not to burn yourself on your glass. When we pull things out of the oven, we're gonna stuff cotton in all of the joints to keep things as dry as possible and keep any water from coming into the system as it's cooling down, all right? So as you put this together, you'll have to pull some of the cotton out to put your set funnel in your condenser in. So you're gonna wanna clamp your round bottom flask, then your condenser's gonna go in the middle joint, okay? And you'll clamp it just like you do a reflux condenser, so you want it nice and vertical. Then you're gonna have your separatory funnel over on the side, and it doesn't matter which side. I would put it on the side of whichever hand you are, okay? So if you're right-handed, put it on the right. If you're left-handed, put it on the left, because it'll be easier to manipulate it that way, all right? And you wanna put all your Teflon pieces back in there, okay? At the start of this reaction, you're going to have, after you get all your glassware assembled, you're gonna put your magnesium in here, okay? You don't wanna weigh out your magnesium till you're ready to use it, because it actually can oxidize sitting in the air. So you don't want it just sitting in the open. So don't weigh it out till you're ready to stick it in your reaction. You'll put your magnesium with your powder funnel into your round bottom flask, and then you're going to put 10 milliliters of the anhydrous ether in here, okay? Then you're going to make a solution of your alkyl bromide, and that is going to go in here. The easiest way to make that solution is you will take the amount of alkyl bromide that you need to use, so you have to calculate that because it tells you in moles how much you need, not how much you actually need. So calculate that in volume, and you're going to have 40 milliliters of anhydrous ether. So I put the 40 mils of anhydrous ether in here, and then put your alkyl bromide in here on top of that. The alkyl bromide's heavier than the ether, so it'll go through the ether and mix with the ether as it goes through. Then you don't have to worry about making this solution. You'll just make it in the separatory funnel, okay? Now, before you put anything in here, make sure that stopcock is closed. The one thing you don't want to do is add all that alkyl bromide to your magnesium all at once. You will get a very, very hot reaction that will get your lab professor moving very, very quickly to get another condenser on top of your reaction, because it will get that hot. And you will quickly kill everything that you've put together here, okay? So you do not want to add the alkyl bromide all at once. It needs to go in there dropwise, all right? And so we're using our separatory funnel to control the addition and add it dropwise, right? So stopcock has to be closed when you go to put your solution in your separatory funnel, right? And then you'll have a little bit of cotton in the top of the separatory funnel, a little bit of cotton in the top of the condenser, all right? Now, your lab manual then talks about the iodine. We're going to add iodine to this before we add our alkyl bromide. The iodine goes in because it etches, it cleans the surface of the magnesium. It helps get all that magnesium oxide off the surface. So that is what forms from the magnesium reacting with the air. So that's why you don't want it sitting out in the air. So we're going to clean it with that iodine and get it all cleaned off, okay? So we'll put a couple of pieces of iodine in there, and then we're going to add our alkyl bromide slowly. You want to have this apparatus checked when it's set up like this before you add the iodine. When you have magnesium and ether in your round bottom flask, you have your alkyl bromide in your separatory funnel, you have your water connected to your condenser and it's running and everything is clamped and ready to go. And we're going to set this up, so you're going to have the bottom of your round bottom flask and the top of your stir plate. You're going to have separation between the two because you're going to use your hands to get the reaction going, to start heating it, okay? So remember, ether, it doesn't take a whole lot to boil ether. What's the boiling point of ether? 33, 34 degrees, so it doesn't take a whole lot. So just your hands underneath your reaction, holding them there, will be enough heat to get that ether to start boiling and get the reaction going, okay? So that's why you leave a gap between your round bottom flask and your stir plate, all right? So once you have all this set up, we're going to come around and check it. Make sure everything looks good before we start adding the alkyl bromide. We'll help you get your iodine in there, and then we'll help you get that first portion of alkyl bromide added, and then what you're going to do is wait and watch for reaction. And what you'll see is you'll start getting cloudy and you'll start have bubbling on your magnesium. That's a sign that a reaction has started, so then you want to keep adding that alkyl bromide to keep that reaction going, okay? So it's going to be a fine line of adding it slow enough that it's not too fast, but adding it fast enough you keep the reaction going. You want to keep a nice reflux going in that reaction, all right? Now remember, this whole time we are not stirring. During the Grignard reagent formation, there is no stirring, okay? So no stirring. And you are using your hands to get it heated, but this is occurring at room temperature. So we don't have any water bath around it or anything like that, okay? Once you get the reaction going and you've added all your alkyl bromide, you're then going to, you want it to reflux for another 15 minutes. And so you should have a pan of hot water ready to put under it, but I would let it keep going on its own as long as it can, and then as soon as it starts dying off, put that pan of hot water under it and start heating that pan of water to keep it refluxing. So remember, if you have really hot tap water, that's going to help it keep refluxing, then you add a little heat to it, it'll keep it going for 15 minutes, okay? You are still not stirring during that 15 minutes, all right? And remember, to set up this reaction, we've used the anhydrous ether, okay? This whole time we've used anhydrous ether. That is in the reagent hoods. There's bottles of anhydrous ether in the reagent hoods. Do not use the red can ether for this reaction, all right? Okay. So then, the next step is our Grignard synthesis, okay? So we've made our reagent, and it's in our round bottom flask, and it's going to stay there, okay? Typically, when you're making Grignard reagents and doing your Grignard reaction, the common things that you react a Grignard reagent with are either an aldehyde or a ketone. Those are the most common that you're going to use for Grignard synthesis. In our case, we are going to use an aldehyde, all right? And so what happens is we've got our Grignard reagent, okay? So that is formed, stirring, or not stirring, hanging out in our round bottom flask, okay? And we're going to add our aldehyde to that reaction, all right? And we talked about how the carbon here, this first carbon on the R group, attached to the magnesium has some nucleophilic character. That means what happens is it can actually attack the carbon of the carbonyl, and we get a bond between those two carbons, okay? And so the intermediate that we form this guy. So R1 came from our alkyl magnesium bromide, which came from our alkyl bromide. R2 came from our aldehyde. Then we've got this now that is formed. And where did that oxygen come from? From the aldehyde, right? That oxygen's from the aldehyde, okay? And so now it is the partial negative charge to be joined with the magnesium, which has the partial positive charge. We're going to react that with sulfuric acid, all right? And so when we do that, we're going to form an alcohol. Okay, so remember our OH group came from here, which came from the aldehyde. R1 was from back here, which came from the alkyl bromide. R2 came from the aldehyde, all right? This is what we want to form this week, all right? But we have to be really careful because it's really easy to go from here to here, which is what we want to do next week, but we don't want to do it this week, okay? So it's really easy to take a water away from this and take our alcohol on to form the alkene, all right? So this is what we want for experiment 8. This is eventually what we want for experiment 11. So we want to stop here this week, okay? So we're going to have to be careful with our workup not to go there. So this first reaction here, call this 1 and we'll call this 2. In number 1, this reaction is actually going to take place in a cold water bath. So the last thing you did here is you were refluxing for 15 minutes, all right? After that is done, you need to remove the water and let it cool down to room temperature, okay? And then we need to actually put it in a cool water bath. Now what we don't want is we don't want an ice bath, okay? If it's an ice bath, it's actually too cold, all right? So we just want to cool a cold water bath, but not ice. If you use ice, you won't get a really good reaction here, all right? Okay, we're going to use our same setup again, all right? So now we've added all our alkyl bromide. It's been refluxing for 15 minutes. We've cooled it down. It's in a cool water bath. We now need to add our aldehyde solution. So in your lab manual, it tells you you're using 0.09 moles of aldehyde in 25 mils of ether. Those solutions are already made. It's already made up for you, okay? So you just have to find the bottle with the right aldehyde and get 25 milliliters of that solution. It is going to go in your separatory funnel as well, okay? So again, make sure the stopcock is closed. We're going to add our aldehyde solution here, okay? When you have your aldehyde solution in there and you're in the cold water bath, then you can start stirring. So we have not stirred anything yet. We are now going to start stirring. And we're going to add the aldehyde dropwise. So we added the alkyl bromide dropwise, we're now adding the aldehyde dropwise. Okay? It's another reaction that we need to control the heat. It's an exothermic reaction, so we need to do this dropwise to make sure we keep the heat under control. The other thing is if you add it too fast, instead of forming the alcohol, you end up forming the corresponding ketone to that alcohol. So we don't want to do that either. So we want to add it dropwise, keep the reaction under control, keep as far as exotherming it under control. You will probably see or hear like little, look like the magnesium's kind of fizzing around and things are popping in the reaction. You may even hear popping. You may even have the cotton on your condenser pop up as the reaction is going. Those are all things that are okay. It's just the reaction as it's proceeding. But we still just want to keep it under control. So you want to add things dropwise, okay? Then once we add it dropwise, Then this one, we're going to stir at room temperature for 15 minutes. So we'll remove the cold water bath, and we're just going to stir at room temperature for 15 minutes. While that is stirring, you want to prepare your sulfuric acid solution that you need for the workup here, okay? You have 9 molar sulfuric acid is what you have, so you need to be careful with it. It's only half diluted from 18 molars concentrated, okay? So it's 9 molar, so it's just concentration cut in half, all right? So be careful with it, handle it with gloves, do not get it on you, do not spill it. But your lab manual gives you instructions for making this sulfuric acid solution. While you're stirring for the 15 minutes, get the solution made, okay? And have it ready to go. After that solution is made, then this part is our workup, okay? This is going to occur in an ice bath. And that sulfuric acid is going to go in your separatory funnel again. So we need that stopcock closed again, and we're going to add it dropwise, okay? And so in your lab manual, it basically gives you the flow diagram to help you understand going through this workup, because there's a lot of pieces to the workup. So we're here, we've got all of our stuff in there, okay? We've got our aldehyde, our Grignard reagent. Hopefully we've made our alcohol, or at least the intermediate on the way to our alcohol. And we're now going to go on with the workup. So we're adding this sulfuric acid solution. We've got to be really careful, because if we get things too hot, it's really easy to go to this alkene, all right? So you have to keep that addition of the sulfuric acid under control. So we've got 3 dropwise additions. We're adding our alkyl bromide slowly, we're adding our aldehyde slowly, and we're adding our sulfuric acid slowly. This is the one probably that it'll feel like you want to race to the finish because you've got to this point yet, but you can't. This is the one you probably need to be actually the most careful with, because it's really easy to get that ether refluxing with adding the sulfuric acid for the quench of the reaction, okay? So we want to add it dropwise. We don't want any ether refluxing, so control the addition. What you will probably see is a lot of different things happening as you're adding it, okay? You'll probably see like maybe some solid appearing, then disappearing. The magnesium's going to be reacting. It'll look like it's got too much stuff in it, and then it'll dilute out and clear out. So there's going to be a lot of changes that you see when you're adding the sulfuric acid solution. What is happening with that is a couple of things, okay? So first of all, we're taking our intermediate here, and we're adding the acid to it, and we're making our alcohol, which is our desired product. Okay? Plus we'll have some magnesium bromide floating around in there, all right? It also is going to react if we have any of our Grignard reagents, or our organomagnesium bromide. If we have any of that floating around, it's going to quench that as well. Okay, so it's quenching our product, making our alcohol, and we'll get alkane corresponding to our organomagnesium bromide, plus some magnesium bromide again hanging around. The other thing that's going to happen is the magnesium itself that's left is going to react with the sulfuric acid, and it is going to make magnesium sulfate, plus then give off hydrogen gas as it's happening. So that's where you're going to see, this will be the solid that you kind of see appear, disappear, and then you also see bubbling. That's the hydrogen gas that's being formed from the magnesium, okay? After you've added all your sulfuric acid, you're going to want to look at your mixture. If you have a lot of magnesium, you potentially want to take on filtering that magnesium off with glass wool, because otherwise you're going to have to just wait for it to finish reacting for you to go on to the next step, okay? So it may be easier to go on and filter this mixture with glass wool and then go on to the next step. What I would do is, if after you've added your sulfuric acid, if you're thinking you're going to need to filter, I would talk to your lab prof and see what they say, okay? But potentially we'll filter it with glass wool, and then what we're going to do is, we've had our ether in there, right? And we added our aqueous sulfuric acid to it, so we now have 2 layers. So the first thing we're going to do is go into our separatory funnel, separate our 2 layers, okay? Then, after you separate the 2 layers, you're going to have your aqueous layer, and you're going to have your ether layer. With the aqueous layer, your lab manual tells you to do something called extract with ethyl ether. What extract means, so extract, one word, means all these steps that I'm going to tell you, okay? So you'll have your aqueous layer in your separatory funnel. You're going to add ether to it. We have water now, so we are not using our anhydrous ether anymore. We're using red can ether for this stuff, okay? With extract, what that means is you are going to add the ether to the separatory funnel. You're going to put the stopper on the separatory funnel. You're going to shake and vent it 3 times. You're going to let the layers separate, and you're going to remove the aqueous layer. All of that is in the word extract, okay? So that is what extract means. Right? So add the ether, put the stopper on the separatory funnel, shake and vent, shake and vent, shake and vent, let the layers separate, pull the stopper off, drain the aqueous layer. Okay? Then that ether layer, we're going to combine with this ether layer. Alright? You are told to wash that ether layer with 5% sodium bicarbonate. So our extraction over here was making sure we got all the product out of that aqueous layer. If there was any product left in there, we were using the ether to get it out, okay? Over here, we're washing with 5% sodium bicarbonate because this still is probably acidic. And so we want to make sure that we've neutralized our ether layer and made sure it's neutral and not acidic anymore. Wash means we will add, we'll have our ether layer in our separatory funnel, add our 5% sodium carbonate, cap it. Be careful because it's going to want to give off bubbles, okay? So maybe give it a good swirl before you cap it to make sure it's done bubbling. Then you'll shake and vent, shake and vent, shake and vent. Let the layers separate. Take the stopper off, drain off the aqueous layer. That's all of what wash means, okay? So all those steps are involved in either one of these, all right? And from here on out, whenever we're doing a workup, if we say extract, we mean what I just told you meant for extract, or if we say wash, it's what I just went through for wash, okay? In the end, we have our ether layer. That's where our product is in the ether layer. What I would do, though, is I would not get rid of any of your layers until you're certain that you have your product layer, okay? So hang on to all your layers and hang on to them separately, okay? Because if you combine this aqueous layer with this aqueous layer, this is acidic, this is basic, you'll get a little bit of a volcano, right? Keep your layers, keep them separate except for combining the ether layers. And then when you have your ether layer, what we're going to do is what's called drying the organic layer, okay? And we're drying we're using a drying reagent, okay? Or a drying agent, either way. So we're going to have our ether layer in an Erlenmeyer flask. What we are going to add to it is magnesium sulfate, which is kind of funny because we were producing magnesium sulfate when we were doing our workup over here, okay? But this time it's anhydrous, it's dry, versus that was in solution. Okay? So the magnesium sulfate, So first of all, magnesium metal. What is magnesium metal going to look like? What you set up your reaction with? It's metal. It's shiny, right? Shiny silver metal, right? I'm testing you on it because the magnesium and the magnesium sulfate are both sitting by the balances. So you got to pay attention to who to use when, okay? So setting up your whole reaction, your Grignard reagent formation, magnesium, the shiny metal. When you're getting ready to dry your organic layer, it's the white powder, the magnesium sulfate is what you're going to use here, okay? And so what happens is the magnesium sulfate, when it reacts with water, when it's anhydrous magnesium sulfate, it complexes with that water. So this is kind of like, it's kind of like flour. It's this free-floating white solid. This gets clumps in it. Okay, so instead of being free-floating, all of a sudden you're getting clumps. And the clumps are the magnesium sulfate reacting with the water, taking it out of the ether. All right? So you're going to put some magnesium sulfate into your ether. The one thing you don't do with magnesium sulfate, don't weigh it. You don't weigh it. Okay? So in your lab manual, it tells you 1 to 2 grams. That's just to kind of give you an idea of how much you need. You never weigh magnesium sulfate. Okay? So you're just going to add it. Just give a swirl to your Erlenmeyer flask. And what you want to see is that you have some that's free floating and then some that's clumping. If all you see is that it's clumping, we need to add a little bit more and make sure we have some that's free floating and some that's clumping. So what you should see is some clumps and some like a snow globe. When you swirl it, it just kind of spins around in there, free floats in there, okay? When you have clumping and free floating, you've added enough magnesium sulfate. What you don't want to do is overdo it and add so much magnesium sulfate you make pancake batter, okay? So if you end up with a slurry, you have too much. You still want just a liquid with some magnesium sulfate that's free floating and some that's clumping, all right? So you're going to give it a good swirl, cover it with plastic wrap, let it sit like 10 minutes, and then you're going to use gravity filtration to filter the magnesium sulfate, okay? And filter it into the round bottom flask that you're going to use to do the distillation to distill your ether, okay? So we use gravity filtration because we don't want it, right? Whenever we don't want the solid, we use gravity filtration. And then the next step after this is we are going to distill the ether with simple distillation. This is the step you have to get to this week, okay? So you have to get to the point where you have distilled off the ether with simple distillation, okay? There is a second distillation where you're going to distill your product to purify it. You will most likely have time to do that next week, right? If you don't get to it this week. If you have time this week, go ahead and do it because then you'll be even farther ahead for next week, all right? But you have to get to where you distill off the ether with simple distillation, all right? So this is our key step for this week. You have to finish this part, all right? And then you want to store your product in your round bottom flask. Make sure you put a little grease on the stopper. Ether is the worst solvent for sucking a stopper into the round bottom flask and making it so you can't get it out and you can't get to your product, okay? So make sure you have a little vacuum grease on your stopper so you don't come next week, you cannot get your product out of your round bottom flask because the stopper's stuck, okay? So put a little grease on it, store it in your drawer until next week. If you have time to do the second distillation, which is a fractional distillation to purify it, what you need to do is you have to be very careful that you know the boiling point of the alcohol that you are making. So you have to use your reaction sheet, predict what actual product you are making, because that's what you're putting in your pre-lab too, is what is the actual product that you are making, and figure out what the boiling point is of that product, all right? It is going to, and it has to be the atmospheric, not under vacuum. So I'll give you the hint that it will be much greater than 100 degrees Celsius, all right? So if you find a boiling point of your alcohol and it's below 100 degrees, that is not the atmospheric boiling point, all right? If you find that boiling point, your instructor can help you. We can do a conversion to what it should be at atmospheric. But just know if it is below 100 degrees, it is not the atmospheric boiling point. So you need to figure out what that is, all right? So at least get to this part. If you get to the fractional distillation, then you may do that this week as well, all right? And then we'll store alcohol until next week. It also talks about in your lab manual, we are going to analyze this with gas chromatography, which we'll talk about next week. We will not prepare the samples for gas chromatography until next week. Okay, so we will do all that next week. What you do need to eventually collect for your experiment 8 product is you will want the yield, okay, and that is after the second distillation to purify it, okay? So you want your yield. You will collect the IR spectrum, which is a liquid, so you'll collect it just like you have for a liquid. With that IR spectrum, you're also going to want to compare it to a literature spectrum. Ideally, you're comparing it to the literature spectrum of what the alcohol you made, but some of these you can't find, so you want to make sure that you compare it to one that's similar, okay? So if you make 3-hexanol, and you can't find 3-hexanol, but you could find 2-hexanol, that would be a good comparison because they're both going to be secondary alcohols. But if you try and compare it to 1-hexanol, that's probably not going to work because it's a primary alcohol and a secondary alcohol. They're not similar enough, and that matters for IR, okay? So if you can't find the exact product, compare it to something that's similar. The other thing that you will then collect and make next week is your GC sample, okay? And so all of these, you will get that, collect the yield, collect the IR spectrum, and make the GC sample after you've done the second distillation for purification. And so what you will be doing is you will be collecting your alcohol. Actually, when you're doing this distillation for purification, you're going to be collecting all of the liquid that boils within about 20 or so degrees of your alcohol's boiling point range, and that will be whatever impurities you have, and then you'll start collecting your alcohol within about 20 degrees of its boiling point range up to its boiling point range, okay? So that's why it's really important you know the boiling point range so that you know that you're collecting your alcohol in the right range and you're collecting pure fractions of it, okay? So you'll probably collect from 20 degrees below to the boiling point range and then collect another fraction that's right at that boiling point range when it sits there, all right? And then you'll do this in your all-in-one simple distillation apparatus, so you want to remember, don't let it go to dryness because you will heat it so hot. You'll bake it in your distillation apparatus and you could actually start a fire because you're heating it so hot, okay? The other thing as far as flammability, if you recall back from experiment 3, remember that ether is very flammable, so we need to take care with it when we are handling it this week. We use it throughout the experiment, so be really careful with the ether. That's why we have to be really careful. Part of why we have to be really careful when we add solutions in ether to not get them too hot. We don't want anything starting on fire. But also be careful of it when you are going to heat things because of the flammability of the ether. All right? Questions you guys have? Okay, just remember, be at morning lab 7:15, afternoon labs 12:45. Okay?